I welcome all and thank you very much for attending this session. Appreciate that. And today we're going to talk about analytical optimization technologies for games and apps. And we'll focus on four of them: analytics, A/B testing, user segmentation, and the newest of the technologies available, dynamic Bestfit. I'm Alan AVIDAN. I'm the chief bees dev at the company. And I actually go back to with optimization quite a long time. I remember fondly the days at Carnegie Mellon University where a group of us was trying to solve some very large optimization problems involving thousands of linear differential equations. I promise you we're not going to do any of that today here, so it's going to be fairly light. But at the risk of revealing my age, I'll tell you that we sat there while the mainframes were crunching those tons of huge problems. If I think I recall, it was an IBM 3033. We were waiting for it then. At the time, we were sitting down and playing Star Wars and Zork and all those good games that pretty much gone, and competing against some pretty crazy guys that evolved from that program. Now, I later continued as a professor at City University of New York, where we also solved some very, very large optimization problems, but that's all history. So let's focus on what we cover today. And in the next 20 minutes or so, we'll cover optimization, what we measure, what can be measured, what can be improved, and the technologies that we use for it. How many of you use A/B testing on a regular basis? Please raise hands. Not that many. How many use segmentation? Also not that many. And I guess I shouldn't even ask how many of you use social data for optimization as a data source. Probably not that many. And that's what one of the points we'll focus on today is the use of social data as a source of finding gold in the heaps of data. Optimization, as you can see, is quite a varied and a complex world. Please relax. We're not going to dive into any of these. I just want to say that in games and apps, we deal with only a small subset with discrete constrained optimization. I guess you could find that on the on the right-hand side there, but that's the last you're going to see that. And just to keep the formality, the last point of the formality, let me pose the problem of optimization for you. Technically, if we really want to do an optimization is to maximize an objective function, which we'll call z, over the variable space x, and it's always subject to equality and inequality constraints. Sorry, that's the formal definition. And but more simply put, optimization is the process by which analytical efforts are exerted in order to improve the performance of our games and apps. So I think you'll all agree with me that we all have rather simple goals. We want to maximize monetization, we want to maximize engagement, retention, and virality. That sounds pretty simple, right? So how can we affect the KPIs, the key performance indicators? Well, by improving our apps, by improving the ways users interact with our apps, by giving our users a better, richer experience, by serving them better, more likable choices. Now, there are many good companies in this field. I'll mention a few here. You can see their logos, each pulling in their own direction, each with a different level of technology and sophistication. Most of them are doing a very good job in helping publishers and developers trying to deal with the ever-increasing amount of data, whether it's social, behavioral, or third-party data. Now, you'll probably need to work with more than one company in order to get to where you want to go. We're not going to be focusing on any particular company, but rather on the underlying technologies that are being used. Now, take a look at this. Here's a case of optimization. This is a case of A/B testing that unrelated to games even. But what you can see is something quite amazing. 88.9% improvement by serving one choice versus the other. 88.9% improvement. Quite dramatic. But in some cases, take a look at this. This is A/B testing. In some cases, A/B testing can produce insignificant results and sometimes even erroneous results. Take a look at what happens when you start out. The bottom, the x-axis there is the number of days, and this is ARPU normalized to 100. What you can see is that the option A, the blue line, initially outperformed option B, the red line, and then mysteriously reversed itself. Not that we understand why, but this is real data after 10 days or so. On the other hand, if we superimpose a different technology that was used using the same data, this is dynamic Bestfit that was used using the same data, then notice that it persistently outperformed either option and performed substantially better. Let me explain that. We'll explain that in just a bit. So, which game elements can you optimize? Well, a lot, quite many. Game flow, tutorial flow, promotions, sharing, payouts if you're running a casino game, themes, landing pages, you name it. There's a lot that we can do. So now let's check out the optimization technologies that are available at our disposal. We'll briefly explore analytics, A/B testing, also known as split testing, segmentation and dynamic best fit. And let's start with analytics. I guess most of you know what analytics means, but here's a formal definition by Wikipedia. Take a moment to read that. But for us, it really means that to access, analyze, and display the performance data and understand how the game is performing, and then how users interact with the game, and then decide where improvement is needed. This can be done and usually requires multiple iterations. As you can see from the bottom, you have to do this multiple times in order to get to where you want to go. We often concern ourselves with engagement tracking of KPIs, MAUs, DAUs, DAU over MAU, average purchases, ARPU, RPPU, D1, D3, D7, D30. You know all these parameters, right? And we also concern ourselves with funnel analysis. We track linear flow, tutorial progress, level, and we track monetization funnel. Very important. Bottom line on analytics. On the upside, you should be capturing as much data as possibly can. But remember that the capture of data, followed by analytics and visualization, can be tedious. And it provides retroactive data about this mysterious average user. Now, there are lots of companies that provide good analytics suites. If you're not using one, it means that you either have developed this capability in-house, or you're well on your way to the dustbins of history. Analytics as a tool, as I said, can be very effective, but think of it a bit like driving a car while looking at the rear view mirror. Here's a nice graphic that I borrowed from a company called Swerve. It depicts very nicely how A/B testing works. It's a primary tool in any data-driven environment, and a lot has been said about it in the media. As we called it, also split testing. It works very simply and very effectively. Think of it a bit as a gladiator fight. You send in your champion versus a challenger, and you embrace the winner. And of course, the loser gets thrown to the lion's den. And it's simple enough. Many game companies have been accused of being so metrics-driven that creativity was abandoned in the process. Those are some of the most successful companies out there. It's also nice to look at what the experts are saying about A/B testing. Here's a synopsis from Quora. First of all, make sure that you know what A/B testing is and how it's done well. There are many pitfalls. You can fall into one of them if you're not testing long enough. If you don't have enough traffic, you can miss out. Believe your gut feelings, but test them. They could be wrong. Test a lot. Test, test, test is the mantra here. You may need dedicated staff for this stuff. And rather surprisingly, sometimes even small changes can make big, big changes in the outcome. The bottom line on A/B testing, it's simple, it's understandable, it can produce dramatic improvements in many ways. Just ask Zynga or Amazon, they're big on this, and many others. On the downside, it can be labor intensive, as we said, meaning expensive. But I think the real problem with A/B testing is different. I think that using one creative, one message, or one payment page and showing it to everybody is not the optimal way to go. There will always be users who would have liked the options you discarded. They may have been the minority, but they would have liked those options. So next, let's talk about segmentation methods. This is where things start getting a little more interesting. There are several segmentation techniques, and we won't be able to cover all of them here, but the basic concept is to create well-defined segments by grouping together users with similar properties. The two common user segmentation techniques are a priori and clustering. A priori, perhaps a more conventional, more intuitive method, create segment definitions that are based on geodemographics, for example, age, gender, traffic source, etc., or on group behavioral attributes. Whales, viral actives, non-payers, killers, explorers, many more. And clustering, I want to think of it as a bit of an inverse direction than a priori. It works it often involves big data and may often touch on privacy issues, not always. Clusters are predefined and in that sense remain unchanged during the analysis. We use segmentation for cohort analysis, which is a standard tool that tracks groups of users, cohorts, which have a common reference feature. For example, a geographic location or a start date. And then tracks and analyzes their retention, monetization, and behavior over a period of time, commonly 1, 3, 7, 30, and 60 days. And then compares how each segment performs and how it affects the KPIs. Now, this is often used in user acquisition to determine which channels deliver best or optimal user profiles at the most cost-effective prices. And for targeting, you analyze current and historical facts to make predictions about future events. It suggests that treating each segment differently to maximize the KPIs. And the bottom line on segmentation, upside can be very effective, especially popular with marketers. Just take a look at the impressive segmentation that the mobile providers have done in terms of plans and phones and all that. They have a plan just for you and with the right phone. That's all based on segmentation. But you need to be very careful. Segmentation is often attempted by intuition, and that can be often irrelevant and way off. You got to be really careful about that. Now, if you're ready to concede that optimization is boring, tedious, and possibly expensive, but it nevertheless needs to be done, wait, there is a better way. There is a better way, and we have saved the best for last. And we're going to switch into dynamic Bestfit, which is a technology I want to emphasize today because it's the newest one. And what if we could find a method like that that extracts the best features of A/B testing, predictive segmentation, and analytics, and does away with all their weaknesses and does it all automatically? That would be good, right? So now, in the remaining few minutes, let's talk about dynamic best fit. First, we need to define what are DNA signatures and what user attributes make up DNA signatures. So take a close look at these. It can include quite a broad range: behavioral, social, session, geodemographic, proprietary, third party, and any combination. I want to emphasize that whereas social data is not critical, not required for use of dynamic best fit, it often is a very, very valuable and very often overlooked source of data. It's an untapped source and now largely available. For example, from Facebook alone, you can extract over 50 user attributes, even under basic user permissions. Now you can see why this kind of analysis has to be done by computers. No human analyst can do this. For example, consider the following numbers. If you have 50 user attributes and you want to optimize 5 to 10 elements in your game, each of them with 3 options, you're going to end up with 750 to 1,500 user attributes to analyze. That's a lot. That's practically impossible, even for your brightest analyst. So how does this dynamic best fit really work? The basic idea is to segment users with similar DNA signatures and then correlate them with actual conversions that occur in the game, then determine in real time which segment the user belongs to and serve them the best page options that their DNA types like more. So this kind of segmentation can, as I said, only be done by computers. And the results are often not intuitive. And the knowledge can be applied to any user and any event point in the game. And users, even users entering the game, even new users that have never entered your game before, all of it in real time. If you want an analogy for this, imagine a restaurant. Let's call this restaurant One Fit All. And this restaurant only serves one 3-course dinner option. And originally, the restaurant had 2 such options, but then realized that one of them sells better than the other and eliminated the one that didn't sell well. And that's a bit, if you think of it, like A/B testing. Now imagine a different restaurant, and we'll call this restaurant Bestfit for all. And this restaurant serves 3 to 5 options per course, but it has no menu. So how does it work? Each customer that walks in, even first-time users, even first-time customers, are automatically served dishes they love most. It's like as soon as they walk in, the chef knows a lot about these people and cooks just the right meal for them from the options available. This is how dynamic best fit works. So, what kind of options what kind of game elements can be optimized? Let's take a look at that. Here's a case where we have multiple page options for a promotional feature. Notice the difference in the wording. Or post on the wall if it's a Facebook app. Here's a different case of a payment page. This time we're talking about different payment ranges. Different incentives on the payment page. Tutorial flow, different options. Different payouts, again, if it's a casino game. Here's a different version of invite friends, different layouts. Promotions, different promotions, take a look at that. You've seen many of these types before. Each one of them gets a different response. Different users like different options and respond differently to each. Here's different creatives. So let's look at some results. As we've seen before, dynamic best fit persistently boosts conversions and KPI. we find that on average 20 to 50% is normal of the improvement in KPIs. In ARPU, how would you like to have a 20 to 50% improvement in ARPU? You would, right? Now, the improvement largely depends on the quality of the options that you can offer. Again, please note that dynamic best fit generates substantially better results than either option A or option B. If you look at that top graph again, the blue and the red line, and then the orange line is the dynamic best fit. For the same data, the same traffic was split 3 ways. What is also fascinating, though, is if you look at the bottom charts, and I know you can't read and understand that. This is, if you want to look at them in detail, please come to our table. But what is fascinating is that the new insights, totally new insights that have never been seen before, are being generated here. And you get those by drilling down to what the machine used to determine what the discriminating factors are between the different options. Which users like which option more, if you drill into that. So these new insights can be invaluable when designing a new game feature or when targeting new users. For example, could you have predicted that users with more than 100 Facebook friends are more readily get to the payment page and convert better? These are non-intuitive, but that's what the machine finds and shows it to you. So let's review. We'll sum it up. A number one take-home from this, the number one conclusion is that you must be aggressively optimizing your present and future games if you want to stay in the game. Furthermore, you need to select the right technology to match your goals. And more importantly, or most importantly perhaps, the amount of available data is increasing exponentially. And there's a lot of gold in those heaps of data. You just need to find the technology that digs into it. And this is possibly the real take-home lesson. So thank you very, very much for your time. And I'll be glad to answer any questions you may have.
2 questions, actually. First question, in terms of exploration versus exploitation, do you have any experience how you best balance that? And second part would be, the problem is, let's say, if you just have a different landing page or so in terms of artwork, that's easy. If you make different prices, the problem is different customers speak to each other, right? So you have all that fairness and whatever. How do you worry about all that?
You're absolutely right. We personally hardly recommend what you should do, but if you ask me, I don't recommend that you use different prices because that can have a negative effect. On the other hand, you can offer different type of incentives. Some people like to see a bonus in percent. You buy these many coins and get 20% for free. And some people would have seen the same, for the same choice, instead of 20% bonus, get 1,000 coins bonus. So that, and there's a different response, different groups. Let me ask you a good question. When you go to the store, what do you prefer? 50% off promotion or 2-for-1 promotion? In essence, they can be the same choice, but different people respond violently differently to these options. So therein lies the secret. In one of the variants that we use, there's always a piece of exploration. You don't use all the data for optimization. You take a piece of it, let's say 10%, and you constantly explore with them new variants in order to gain new knowledge about because user base changes. It could be just over time you have a different user base that has different preferences. So you don't just learn and then apply it forever. You keep learning as you go. You constantly learn, and you constantly also benchmark. How do you know you're causing any improvement? So another piece of the data is unoptimized and always used as a benchmark, as a reference to see that you are creating an improvement. 10% is a good number, depending on your traffic. Obviously, you want to have statistically meaningful numbers, so it really depends on volume. But 10% is a good number.